welcome you all to this session. And today, you see, we are going to see about the machining process, which involves more than one operation or more than one cutting tool. Say, for example, drilling of different hole sizes or drilling and milling means multiple cutting tools involved in machining. So such cases, let's take an example of drilling of different hole sizes. See, this is the product. In this product, you see, this is the profile, how the workpiece looks like. This is a projected area at two places, and it has around 10 holes. Out of 10 holes, 8 holes are of same diameter. Hole number 1, 2, 3, 4, and 5 is here, 6, 7, 8. Hole number 9 and 10, these two are of different diameters, whereas the hole number 1 to 8 are of different diameters. I have shown that here hole numbers 1, 2, 3, 4, 5, 6, 7 and 8 are having diameter of 10 mm, and through holes means they are continuous holes from top to bottom surface of the workpiece. And hole number 9 and 10, the diameters are 15 mm diameter, and they are also through holes, but the positions are different. I have given in red color because it is not so visible. The 4 is not so visible, so I've just for visibility I have shown again the numbers in red color one, right? So this is how the workpiece looks like, and we have to make an operation. So here we need to go for two types of cutting tools. One is, two are drill bits. One drill bit are of diameter 10 mm, another drill bit are of diameter 15 mm. So here in this operation we need to go for a tool change in between the operations. When you change the drilling hole from diameter 10 to diameter 15, we should go for a drill bit change. That is we call as a cutting tool change, M06 command. So while changing a tool number one tool to the another tool, we should use the command called as optional stop. That optional stop command is written as M01. M01 means optional stop. Okay, that's what we are going to see here. Now before going to the program, we have to the first step what I told you is to find out the coordinate values. You can see the coordinate values 1 at the point 1, what is xy, what is xy at 1, 2, 3, 4, 5, 6, all these points. So I don't have space to write all these things again. I hope you will find yourself, because the dimensions are given here. Say for example, if you take point number 1, the value of x is 10, value of y is 10 plus 20, 30. So here 10 comma 30. Here at 2 it is 10 comma 10. 3 it is 30 comma 10. So like this we can find randomly. If you say if you take the point number 6, the distance of x is 60 plus 20 plus 10, that is 90, and y is 10, so 90 comma 10. So like this you can find out the the position, the coordinate positions of all holes. That is the center point of all these holes. It is known to us. Second thing, the depth of hole. If you see the workpiece, you see the blue color ones, we call it as origin. It is also called as workpiece 0 point. It can also be called as a workpiece origin, because the origin it is a place where the values of x, y and z are 0. See, this is x direction, it is 0. This is y direction, it is 0. And this is z direction, this is 0. Okay, in top view you get the z directions. So you see, this is x and y is perpendicular to us, and z is in vertical direction. Above is positive, below this point is negative z direction. Okay, this is the idea. So now in this program we have to use canned cycle to do the drilling operation for all these holes 1, 2, 3, 4, 5, 6, 7, 8. So for doing all these things, you see, it is easy to repeat 1, 2, 3, 4, and to travel from point number 4 to point number 5, or the hole number 4 to hole number 5, we need to go to initial point, because there is a small projection. The workpiece is having this kind of shape. So this projection is 10 mm above the work surface. So initial point should be more than 10 mm. That is Z value should be Z12, Z13 like this. Okay. So with this basic informations or basic knowledge about this product, now I think we can go for programming. And of course, one more thing, we have to do the sequence of operations. Here two different types of cutting tools are used. The programmer or the designer, the engineer has to sequence the operations. Which operation he will be doing first, which operation he is doing second. Okay. Here we have only two operations. One is drilling of 10 mm diameter, another one is drilling of 15 mm diameter. So some engineers may use 10 mm as first option, 15 mm as second option. Some may use 15 as first, this as second. So as they like. But in this program, I think we have taken 1 to 10 as first. So 10 mm diameter we have taken as first operation. After finishing, we go for hole number 9 and 10 in this sequence, in this numbering order, right? Okay, now let us come to the program. You see here, as usual, this is line number 1, block number 1, 2, 3, 4, etc. continuously it is written. And first is to start from machine home point and change the tool. We are choosing the tool number 3. What is tool number 3? It is drill bit diameter 10. For the holes number 1 to 8, it is written 1, 2, 3, 4, 5, 6 till 8 holes. We are using this diameter. Okay, first tool change. Then setup phase, again G90 obsolete programming. Again same, the position, the first position from home, it goes to the first hole number 1 position, but at a height of Z12. Okay, Z12. And speed, start spindle, start coolant as usual. So the first is Z X10 Y30. X10 Y30 means hole number 1. X is 10, Y is 30. So it goes here. That means at this place. When the tool is coming from home point, it comes over here. It doesn't go closer. It should be above 10 mm. So Z12 it is here. And then we go for drilling cycle, canned cycles, and go to initial point. Then go to hole number 5. Again canned cycles. Go to initial point. Then go to home point. Then change the tool, means drill bit diameter 15. And then again come to hole position 9. Go do the two operations. Again come to initial point, go to home, finish. This is the idea. Now let us see here. Setup phase is finished. And then comes the next block is about G99, that is the initial point, repeat point return, and G81, it is a drilling cycle. We are not using Peck drilling here, we are using drilling cycle. Drilling cycle means in one stroke it completes the one hole. Okay, drilling cycle, same point, hole number 1, I have written here hole number 1, and the depth of hole is 15. This is 15 mm is the depth, but we are giving minus 17 because it is a through hole. Better to make 2 mm 3 mm extra. So Z is minus 17 and repeat point is 2. Repeat point 2 means just above the workpiece surface, as I told you in previous examples. And feed is this. So the explanation of this block I have shown you here. Hole number 1 and repeat point return means after hole number 1 it goes to repeat point. Then hole number 2, hole number 3, like this. So this is what I given you. Hole number 2, the dimension is given here. X is not changing, Y is changing. Okay, hole number 1 is here, hole number 2 is here, 10, 10. Hole number 3, 30, 10. So Y is not changing, X is changing. So 3, 4, 5 I have given for 4 holes. After 4th hole is completed, the tool has to come to initial point return. So I have given you after hole number 4, G98. That means initial point return. The initial point is Z plus 12. That is above the maximum height of workpiece. That is 10. So above 10 is 12. 12, 13, 14. I have taken 12. Okay. After this again, the tool should go to hole number 5. From hole number 4, tool should go to hole number 5. Hole number 5 is here. This is hole number 5. So it should go to here. So the hole number 5, the position is X is 90, Y is 30. So X is 90, Y already 30 is here. So just give the value for X, it goes to hole number 5 and it will set for the repeat point G99. That is why after G98 means when the tool comes to the initial point, you just write, then next block should be G99 and the position of hole it takes. And in that area we have 4 holes, 5, 6, 7, 8. 5, 6, 7, 8. So 5 is here, give for 6, 7, 8 hole coordinates. After finishing, again we should cancel this. Cancel the canned cycle, G81 cycle we have to cancel, because this diameter 10 is completed. So we cancel and go back to home position and change. So after finishing this hole number 8, we go for G00, G80, Z12, means it is coming to initial point. After finishing 5, 6, 7, 8, it goes to initial point. Then we cancel this, and then we go to stop the spindle, stop the coolant. Afterwards go to initial point. After going to the machine 0 point G28, it will go for a command called as optional stop, that is M01. M01 means optional stop. This optional stop is used only to change the tool from the current tool to the new tool or to the next tool. Okay, so we tell the machine optional stop M01. Immediately after M01 we use change tool, tool number 7. Some number I have given 7. What is this tool number 7? Tool number 7 is again drill bit, diameter 15 mm. So from diameter 10 mm we have changed, we are changing the new tool having diameter 15 mm for hole numbers 9 and 10. Okay, for this hole 9 and 10. So this is changed. After this changing the tool, again it repeats like this, these blocks. Again G90, G00, see, G90, G00, X60, Y28. That is X60, Y28. This is the position for hole number 9. Here we have only 2 holes, hole number 9 and hole number 10. So hole number 9 is X is 60 here, because it is given as center point 60, and Y is 10 plus 20, 30. So 60 comma 30. This is 28. This hole is little down, so take it as 28. And Z12. Z12, this hole is also having a depth of, Z12 means the tool will come to this position. Okay, not this is 10, this is 12 at this position. So the tool from the home point, from the machine home point, it comes to this position. Afterwards, we should use the cycle. That is G99 means repeat point return, same like this. G81, same X60, Y28, Z minus 17, R2 and F80, same. Here this is for hole number 9 and repeat point return. After this go to hole number 12, hole number 10. Hole number 10 is at a distance of 12. You can see here the distance 12. This distance is 16. So 12 plus 16 is 18. The distance of 9 and 10 is given here. 12 plus 16 is 18, 28. This is 12, 10 is 12. So Y is 12. After finishing this hole number 10, we will tell go to initial point. Means here after finishing this 30, we say go to initial point. Same here, after finishing hole number 9 and hole number 10, it goes to initial point. Initial point means Z is 12. It goes to initial point. After initial point, again cancel G00, cancel the canned cycle, G80 and Z plus 12. Canned cycle cancel. And then stop spindle, stop coolant, go to home point, end program. Okay. So this is how we do the program for this operation. The operation is same. I have given more number of holes just for practice purpose, and I have given 2 different hole sizes. One is of 10 mm dia, other one is of 15 mm dia, where we need to change the tool. When you are changing the tool, you should go to home point and then make the machine for optional stop M01. After that, change the tool and then continue for the next tool operations, right? So this is all about this program. Hope you understood. Now let me explain you the same program using the command called Peck drilling cycle. That is, instead of using G81, let's use G83. Everything will be same except changing G81 to G83. When you change G81 to G83, here after Z you will have one more value called as Q, that is incremental depth of cut, Q. Okay, give some Q value and finish. All coordinate points are same because the product is same product. Coordinate points remain as is. there is no change in X and Y values. Only change, instead of G81 we change G83. Since G83 is there, Q will appear here. That's it. Why we do this? Because to handle more to handle more heat, and also to remove the chips outside the workpieces because of more depth of cut. Instead of 15 in one stroke, we can go 2-3 strokes. That is the only advantage of peg drilling cycle. Let's see that program in the next slide. Okay. Yeah. So this is I have used G83. In previous one, I have used only G81, G98, G99, M06, M01, optional stop. So here in the next page, I have used G81 and G83 I have used, and G98, 99, M06, M01. So if you see here, there is G83 for first holes and G81 for the second hole number 9 and 10. It is same like previous. There is no Q value here, but in one set of holes, small diameter holes, 10 mm, I have given G83. So I made it in a bold color to make you understand. See, G83 means Q4. Remaining everything is same. Initial point return and repeat point return, everything is same. And here there is no change. Okay. Only advantage is to reduce the heat, cooling purpose, and remove the chips outside. Okay. So here I have shown you, use peg drilling cycle for holes from 1 to 8. So only from 1 to 8 you should use peg drilling cycle, 1 to 8. Hole number 9 and 10, they are not telling anything, so just use normal drilling cycle. But in both peg drilling cycle, there is G80 to cancel the canned cycle, and for normal drilling also there is G80 to cancel the canned cycle. Okay. So this is how the program has to be written when you are asked to use the peg drilling cycle, G83. Okay. So with this, I am finishing this session, this lecture, and in the next session let us see some other product where both drilling operation and end milling operation joins together. This is also multiple tool operation. This we will see in my next session. Thank you all of you.